Let's try that.
Boy, he's been at that quite some time now. Sometimes an electrical problem just won't show itself. He did it again. That circuit's never going to work until he stops letting the smoke out.
The great American road belongs to Buick.
In the case we've just seen, the source of the problem is a poorly taped splice. The tape came loose, allowing the wire to touch metal and short. Eventually, he will find it. In the meantime, let's talk about wires and connectors. These two wiring harnesses represent but a small fraction of the total wiring system in a typical Buick. This is an engine harness, that an instrument panel harness. Over the lifetime of the vehicle, few problems specifically trace to actual harness faults. Of the problems that do occur, there are 5 common wiring problems. Now, the vast majority of electrical problems have humble beginnings. Electrical trouble most frequently starts out as pinched or broken wires. A wire caught between two objects, like a panel and the sharp edge of a bracket, can cut through the insulation and short the circuit. A cut or broken wire can create a momentary short circuit as the wire is cut. Then the circuit remains open or causes an intermittent problem. When repairing these conditions, be sure to route the repaired wire away from the item that caused the initial problem. The third most common wiring problem is a partially disconnected connector. This may leave some circuits okay while others are intermittent or open. The small connector position assurance lock, or CPA lock, eliminates the loose connector fault. However, CPA locks must be removed to separate the connector. In addition, CPA locks must be reinstalled to lock the connector halves together. The fourth ranking common problem is bent or damaged terminals. A bent terminal may not retain contact with its mate. The result is an open circuit or intermittent problem. Or, if a terminal is bent enough to touch an adjacent terminal, a short circuit may result. When dealing with a terminal problem, be sure to inspect both connector halves for damage. If the mate is okay, then replace the damaged terminal. The fifth most common problem occurs when a terminal backs out of its connector. This results in an intermittent or open circuit. Most terminals incorporate a lock tang. The tang catches and holds onto the interior of the connector cavity canal. If the lock tang is damaged, the terminal tends to back out of the connector. Another possibility for this condition is a damaged connector body. If there is internal damage, then the lock tang has nothing on which to hold. Replace the connector body. The small terminal position assurance lock, or TPA lock, eliminates loose terminal problems. Remove the TPA lock before attempting to remove the terminal. In addition, the TPA lock must be reinstalled to lock each terminal in the connector. All these electrical problems have one thing in common. They're all easy to correct if you have Terminal Repair Kit J38125. The kit is a complete electrical repair arsenal. It has the tools and parts necessary to repair connectors and wiring to original factory specifications. The kit includes 5 different special tools for removing terminals from connectors. These tools are a standard large pick, a standard small pick, safety pins, a weather pack pick, and a micro pack pick. The kit includes 3 special crimp tools. Each tool can form a variety of crimps. This tool forms terminal crimps 1 through 5. This one forms terminal crimps A through E, and this one forms terminal crimps F and G and salmon, blue, and yellow splice sleeves. Choosing the right terminal crimp tool requires 3 bits of information: the type of terminal, the terminal number, and wire gauge. Cross-referencing these facts leads to a crimp to a letter or number. This is the only way to find out which crimp tool to use, but the result is a crimp just like you see from the factory. The supplemental inflatable restraint lead set is an extremely important part of the repair kit. Each SIR terminal is gold-plated for maximum conductivity. There are no substitutes for these terminals. An important part of the kit is the Ultra Torch. It is a butane torch used for crimp and seal splices and to solder terminals. The kit contains 2 boxes that hold various terminals, splices, and environmental seals. Terminal types are divided into 4 groups: the 56 series or standard terminals, MetriPack terminals, MicroPack terminals, and WeatherPack terminals. These are all the terminals used throughout Buick vehicles. Standard terminals are available in 3 variations. MetriPack terminals are available in 20 variations. MicroPack terminals are available in 3 variations. WeatherPack terminals are available in 2 variations. Regular splice clips crimp together 2 or more wires and require solder and tape to keep out corrosive moisture. The newer crimp and seal splice sleeves, however, crimp together only 2 wires. The sleeve requires a minimum heat of about 375 degrees Fahrenheit to drive away corrosive moisture. The heat shrink tube has special glue inside that adheres to the insulation for an airtight, moisture-proof seal. This splice is advantageous in the engine compartment. These silicone environmental seals are a part of the sealed WeatherPack and sealed MetriPack connectors. They keep contaminants away from the terminals by sealing each wire within the connector body. Many automotive systems rely on sensitive electronic circuitry like coolant sensor signals or distributor reference signals. Excessive resistance across just one connection can affect engine performance. The terminal repair kit contains just about everything needed to make factory specification repairs. Okay, now let's see how to attach splice clips, install crimp and seal splices, and perform terminal replacement procedures. When attaching a splice clip, remove about 3/8 of an inch of insulation from each wire. Just be careful not to nick the strands. Any strands with nicks soon weaken and break from constant vibration, so don't hesitate to start again. Small splice clips splice 2 wires. They're crimped in jaw F. When splicing 3 or more wires, use the large splice clip. Insert all 3 wires into the clip. Crimp the splice in jaw G until the tool automatically releases. Always solder splice clips to help avoid corrosion. A solder joint is good when the solder runs freely throughout the clip. When the splice is cooled to the touch, roll electrical tape around the splice to approximate the thickness of the insulation. Do not flag the tape. The flagging may adhere to other components, become loose and expose the splice, and invite disaster. This is an example of a proper multiple wire splice. Be sure to always splice at least 1.5 inches from another splice, terminal, or component. The use of crimp and seal splices for SIR system repairs is essential. Before attempting to repair a faulty wire in the SIR harness, disable the SIR system by removing the Diagnostic Energy Reserve Module, the DERM, from the circuit. This prevents an accidental airbag deployment. To disable the SIR system, disconnect and tape the negative battery terminal. Since the SIR Diagnostic Energy Reserve Module, or DERM, has a 10-minute 36-volt reserve charge, remove the SIR fuse. Then, disconnect the yellow 2-way connector at the steering column base. This takes the inflator module out of the circuit, eliminating the chance of accidental deployment. Next, Use the special micro-pack tool to remove the terminal from the connector body. Remove the damaged portion of the wiring and strip about 3/8 of an inch of insulation from the harness wire. Measure the wire's gauge. Then, using the gauge size, choose the right crimp and seal splice from the chart. To find the right crimping location on the tool, match either the gauge number or the splice color. Place the splice in the splice sleeve crimp location and crimp just enough to hold the splice in place. Insert the wire and crimp until the ratchet releases. The ratchet allows the tool to exert a preset uniform force to every crimp. Cut and strip a new SIR lead from the SIR wire and cable repair kit. Place the other side of the splice in the crimp tool. Insert the new lead and crimp until the ratchet releases. Tug gently to see if the splice will hold. Now that the crimp is tight, the splice sleeve must be heated. Install the heat shrink adapter to the tip of the ultra torch. To ignite the ultra torch, open the shutter knob and move the gas control lever to 3. Then move the on-off lever to the on position. Light the end of the torch and close the shutter. The heat shrink attachment is almost instantly ready for use. Heat the center first, then each end. Be sure the glue is visible at each end of the splice. To check the repair, use the wiring diagram to locate the connectors at each end of the circuit. Set a volt-ohm meter to an ohm meter range and check the continuity of the circuit. This should be done after every repair, not just SIR repairs. After verifying the repair, wrap the harness. Then apply a yellow SIR circuit caution sticker from the kit to the harness. Reconnect the DERM connection. To place the system back in service, reconnect the yellow two-way connector. Next, reinstall the SIR fuse and reconnect the battery. Switch the ignition on. The inflatable restraint light should flash 7 to 9 times to indicate that everything is working properly. If the light does not flash 7 to 9 times, refer to the service manual. Remember that all SIR terminals are gold-plated, so be sure to use only SIR terminals from the kit. Now, let's see how to repair WeatherPack, 56 series, MetriPack, and MicroPack terminals. On a WeatherPack connector, start by opening the CPA lock, then separate the connector. Be sure to remove the TPA lock too, if it has one. Release the lock tang to remove the terminal. To minimize wire loss, cut off the terminal between the core and the insulation wings. Then strip off 1/4 of an inch of the insulation. Place a new cable seal over the end of the wire. Hold the new terminal in the tool. Insert the wire and crimp until the tool releases. Repeat the process on the cable seal and insulation crimp. Apply solder to the core wing crimp. When the terminal is cool to the touch, insert the terminal into the connector. Electrically check the repair for continuity. Then install the TPA lock, connect the two halves, and install the CPA lock. Series 56 or standard connectors separate similarly, but use the standard large pick to release the lock tang. All other procedures are the same, except Series 56 terminals do not use silicone seals. Use the safety pin to remove 150 series MetriPack terminals. Sealed MetriPack terminal replacement procedures are identical to WeatherPack procedures. Not all MetriPack series terminals, however, are sealed, so they are a little easier to repair. Replacing sealed or non-sealed MicroPack terminals is similar to replacing WeatherPack terminals. However, use the green handle tool to release the lock tangs.
Okay, now that'll do it.
Hey, it looks like you found the problem. Poor taping from a previous repair on a coolant sensor circuit splice came loose and shorted the circuit. But that won't happen again. There's nothing more satisfying than a job well done. Just be sure to electrically check every wiring repair and keep that smoke inside the wiring where it belongs.